In this video we will discuss about FAK. Phosphorylation is linearly dependent even at high forces. So in order to check the FAK phosphorylation relationship at high forces, what they did is they designed a system where they use magnetic beads. So what this magnetic bead does is they keep the cells in this mPAD on and then coat this magnetic beads with fibronectins and then place these magnetic beads into these mPAD systems for some times, and thereafter you apply the magnetic force and then check the impact of this FAK phosphorylations on this increased force. And this is the graphical representations, and these are the magnetic beads and how the magnets are being applied after given enough time for the magnetic force to bind to the integrins of the cells. And this is how it will look like. And so what I first checked, and for the negative control they use the suspended cells which are not under any magnetic beads interactions. They can act as a negative control. So first they check for the wild type FAK. When the wild type FAK presents within the cells, they see increase in the activations of the FAK, that is phosphorylated FAKs to TFAKs levels increased with increased amount of with increase in the number of with increased in the force. And from this it seems like the FAK phosphorylations is linearly dependent even at higher forces. So then they also check it at different other conditions, that is when there is no FAK presence. In that case also they can see that there is some minimum activations of the phosphorylations which can be considered as background signals at zero forces. And when they introduce this FAK of this E1015A mutant in the FAK null cells, they can see some increase in the phosphorylations of the FAK, but it does not show any kind of relationship with the forces. Thereafter they use the Vinculin wild type, and in this case also they see an increase in the activations of the phosphorylations with increase in the forces. And when they don't see Vinculins, they see reductions in the activations of the phosphorylations. And when they use the Vinculins with the mutant at A150I, then also they see reductions in the activation of the phosphorylations compared to the wild type Vinculins, and it does not show any concrete relationship with the forces. And they validate their results using or these results are being plotted based on this Western blot that are done on this kind of experimental samples, where we can see that for the first panel on left hand side panels of the left hand side figure of the panel B, Western blot corresponds to the left hand side figure of the Western blot of the panel B, where we can see that the TFAK levels are increasing. TFAK levels are almost remain constant, but this phosphorylation levels continues to increase. But when there is null FAK, we do not see any we see minimum phosphorylations of the FAK, and similarly total FAKs also goes down. But when they use the mutant E1015A FAK, they see an increase in the phosphorylations, but they also see some increase in the total FAKs, increase in the phosphorylations of this FAK and total increase in the FAK, and the overall ratios does not gives us any concrete relationship between activations of FAK and the total FAK. And for these Vinculins also you can see an increase in the activations of the FAK, but there is no increase in the total FAKs, indicating that it's the activation that is increased. And for this no Vinculins or null Vinculins, we see some decrease in the activations of the FAKs, and similar results we have seen when they used mutant VCLs, that is at mutations at A150 with I. Here also we do not see any significant increase in the activations of the FAK, and there is no relationship has been established between activated FAK and the force. So all this in together indicates that even if these activations of FAK are being checked at high pressures at wild type FAKs and wild type insulins, we can see a linear relationship. The linear relationship between the force that is exerted by the observed by the experienced by the cells and the experienced by the cells, or we can say this integrins, and the activations of this FAK, focal adhesion kinase pathways. I hope you understood how they validate the phosphorylated activations of the FAKs at high forces. If you need to understand more about their experiments in detail, you can go through the reference that has been provided in the description. That's all for this video. Thank you for your time.